Today's lesson is on solving equations with the variable on each side, and it's going to be a longer lesson, so it's going to take 2 days. So this is the first day. My first problem today is 2 plus 5k is equal to 3k minus 6, and the directions say to solve the equation, which is what we're going to be doing in all our problems today. So there's my wall. First thing I want to do is I want to get my variables to one side and my constants or my numbers to the other side. If I can, I would like my coefficient to be positive, and remember that the coefficient is the number found right before the variable. So I have a 5k on the left, and I have a 3k on the right. So I'm going to bring my 3k to the left and do the opposite operation so that I end up with a positive coefficient, which is 2k. Rewrite whatever else I have. Now again, my variables are on the left, so I need to get my constants to the right. So I have 2k is equal to negative 8, and k in this problem is equal to negative 4. Now the great thing about these problems, especially on a quiz, I can always check my answers. So all I need to do is wherever I see k, I'm now going to substitute with a negative 4. So I have 2 plus 5 times negative 4 is equal to 3 times negative 4 minus 6. So I have 2 minus 20 is equal to negative 12 minus 6. So I have negative 18 is equal to negative 18. Now that's a true statement. It doesn't matter what values I get there. It's just the fact that that is a true statement for there. So therefore, I know that k is equal to negative 4 is a correct answer. In the next problem, I have 3x minus 10 plus 4x is equal to 5x minus 7. Now when I draw my wall at my equation, I notice on my left-hand side I have more than one variable. So before I start moving things around, I always want to combine my like terms on each side of the equation. So my 3x plus 4x gives me 7x minus 10 is equal to 5x minus 7. Now again, I'm going to try to get all my variables to one side and my constants or my numbers to the other side because I have a 7x on the left and a 5x on the right, and I want to keep my coefficient positive. I'm going to subtract that 5x to both sides, which gives me again positive 2x minus 10 is equal to negative 7. I add 10 to both sides, and I have 2x is equal to 3, so x is equal to 3 over 2. And it's okay that I have a fraction. That's going to happen sometimes. It's an improper fraction because my numerator is higher than denominator, which is fine. My next equation says 4 times the quantity of 1 minus x plus 3x equals negative 2 times the quantity of x plus 1. So not only do I have variables on both sides of the equation in this problem, but I also have parentheses. So I know with my order of operations I need to get rid of my parentheses first. So I draw my wall, and now I'm going to distribute. So 4 times 1 gives me 4. 4 times negative x gives me negative 4x. Be careful of your sign there. Plus 3x is equal to negative 2x. Again, I'm distributing, minus 2. So I still have variables on both sides. On my left-hand side, I need to combine my like terms first. So that gives me 4 minus x is equal to negative 2x minus 2. I'm going to add my 2x to both sides, so I have a positive coefficient. If not, it's okay. It'll still work. So I have 4 plus x is equal to negative 2. Subtract the 4 from either side, and I have x is equal to negative 6. In our next problem, we have 1/4 times the quantity of 12x plus 16 is equal to 10 minus 3 times the quantity of x minus 2. So again, this problem is a little bit longer. We have a fraction in the front, which usually makes students nervous, but I always say, well, what would you do if it were a 2 or a 3 or a 5? And you would just distribute. So 1/4 times 12x is going to get me 3x. 1/4 times 16 gives me positive 4. So just by distributing, I was able to clean that up and get rid of my fraction, is equal to. Now on the right hand side, I have 10 minus 3 times the quantity of x minus 2. So I really have to pay attention to order of operations. Parentheses comes first. So I do not want to combine the 10 minus 3 first. I want to distribute that negative 3. So I'm going to rewrite the 10, and now I'm going to distribute that negative 3. So I get negative 3x plus 6. So there's my wall. So when I want to combine what I have, so my left-hand side stays at 3x plus 4 is equal to. Now I can combine my 10 and my 6. They're like terms, so I have 16 minus 3x. Now again, my positive 3x is on the left-hand side, so I'm going to bring this to the left-hand side so I can deal with a positive coefficient. Makes things a little easier, not that it's wrong if you go the other direction. So I have 6x plus 4 is equal to 16. Subtract my 4, and I have 6x is equal to 12, so x is equal to 2 is my final answer. Number 5 is a slightly different problem, so we have x minus 4 over 2 is equal to 6 over 7. So when we have a fraction on either side of an equal sign, we can cross multiply. So what that means is I'm going to multiply one numerator by the denominator, and I'm going to do the same thing on the other side, a numerator by the denominator. So when I do that, I have 7 times the quantity of x minus 4 is equal to 2 times 6. So I'm going to distribute, so I get 7x minus 28 is equal to 12. There's my wall. I'm going to isolate, so I've add 28 to each side. I'm going to isolate my variable, and I get 7x is equal to 40. Divide both sides by 7, and I have x is equal to 40 over 7, which I can either change to a mixed number or just leave it like that. Number 6 is a similar problem, so I'm going to take a numerator from one fraction, and I'm going to multiply that by the denominator of the other fraction, so I have 3 times the quantity of m minus 6 is equal to 5 times m, which is 5m. Again, I'll distribute, so I have 3m minus 18 is equal to 5m. There's my wall. I already have 5m on the right-hand side, so I'm going to bring all my m's to that side, my variable. So I'm left with negative 18 is equal to 2m, so m is equal to negative 9.